Hey everyone, my name is Anvita Bansal and we are back with another lecture based on bit manipulation. Let me just check if you guys are able to see my screen. Let me just have a look. Check if yes, I think we are live. Fine. So let's start with today's lecture. So the question that we are going to discuss today is rotate bits. Let me just okay. So starting off with the question, let me just show you there was a little connectivity issue. So coming back to it. Fine. So rotate bits is the question. Let us have a look at the problem. Although the problem statement, the word itself is evident enough that what we are going to do. We are going to rotate the bits by d positions. You are given a number d, integer d here, and you have to rotate that bit by d positions to the left and d positions to the right, and then the number that you're going to get, that you have to return. So let's once give a read to the question. Let me just take this off. Okay, so given an integer n and an integer d, rotate the binary representation of integer n by d digits to the left as well as to the right, and return results in their decimal representation the way they are given as inputs. And note, this is important, n is stored using 16 bits, that is 12 will be stored as this, and so on and so forth. I will explain it to you. So I hope you understood the question. So let's just see how to solve this question. Let me just take this example test case and I will explain. Okay, so moving on to this, first of all, what you are given in the question, you are given n, right? Let's say in first test case you are given n is 28 and d is 2. Okay, so how do you rotate the number n? Obviously we want to work on the bits. We want to rotate the bits, and then the number that is found after rotating the bits by d digits, then what is the number found in its decimal form, that is what we have to return. Okay, so if I show you binary representation of 28, is it 28? Yeah, so binary representation of 28 that they have given is triple. I'm just right away taking it from your example. I'm sure you know how do we don't have to literally convert it to binary, but we know that when we are going to use operations, they will be operating on the binary form of the decimal number. So that's very clear in the from the previous lectures also. Okay, so what they have given us is that any number will be represented as 16 bit. So when we say 16 bit, we will append zeros. Okay, so that means from 16, this is the binary representation of 28. Okay, but how many bits are these? 1 2 3 4 5, and we want total 16 bit number. We want a 16 bit number, so we will append 16 minus 1 5 number 11 zeros to its left. Okay, so forget about being 16. Don't focus on a number being a 16-bit number. Just focus on this thing. Let's say we have a number like this, 11100. Now I want to rotate it by 2 digits. Okay, I want to rotate it by 2 bits. So when I say left rotate, I have to rotate it to the left also and to the right also. When I'm saying I am rotating it to the left, I am basically moving the bits from this position, rightmost position, to the leftmost position. Okay, so you can say the once when you rotate it, 0 comes here. Another time when you rotate it, 0 comes here. Okay, so you have basically rotated this number by 2 times, its bits by 2 times to the left, right? Because we are moving it to the left position. So the final number that we got is 00111. So actually, what is this number? If I want to represent it in its decimal form, then it is nothing but 2 to the power 1 plus 2 to the power 2, 4 plus 2, that is 5, I think, if I'm not wrong. Okay, let me just see, plus 1 into 2 to the power 0. What is wrong here? I think the answer, when we rotate it left, it is, right, just give me a moment. Sorry, there was a little. Okay, so I'll just reiterate what I said. I told you that we are shifting the numbers, rotating the numbers to this position, right? But eventually your bits are getting shifted by two positions to the right. So this will be considered as a right shift, okay? So you can just understand it this way. And vice versa will be the left shift. So finally the number that we will get, finally the number that we are going to get after shifting this by two digits will be this number 00111, and 00 how many times, as many times, so your number ultimately will be 00111. Fine. So these will be number of zeros such that the entire number is a 16-bit number. Okay, fine, this is your right shift. What about left shift? If I talk about the same number doing left shift, so your original number was 1110 when I am doing a left shift on it, I would want to move my number to the left, right? So if I am doing so, what I'm gonna do, I will basically move bits one by one to the right side, right? So once when I moved it, I got a number like this. Another time when I moved it, I got a number like this. Okay, so this is how you're going to get your number, and this becomes 10011. What is wrong? Have I written 1110? Rotating left by two positions. Okay, rotating. Just give me a second. I think there was a mistake here while explaining you guys. Just a moment. What we want to do here is, this is not the kind of rotation I was assuming it to be. So let me take this again. So this is the number you have. Let's say I am doing a left rotation. Okay, I am doing a left rotation on this number. So when I am doing a left rotation on this number, I am shifting every bit to the left one by one, as many times it is given us to move. So if this is your number 11100, you shift it to the left, two times. So when you do so, how many bits you will have here total? Let's say this is the entire number, I am doing a left shift on it. So the first two bits from this position will be moved to this position. Now what is the number that you are getting? So you are going to get two more zeros appended here. So this is the number you are going to get. Fine. Now when you have this as your number, so this is the left shift. Okay, I hope now it is clear to you all. This is the number that we are going to get. If I do the right rotation, also please do not get it confused with left shift, left rotation. Left shift is different, left rotation is different. So that is why we are solving this question, because both are different things. Okay, coming on to doing a right rotation. In right rotation, what are we going to do? We are going to shift the last two bits from here, right? Okay, so each of these bits will be shifted two positions here, and these zeros will be appended this side. Okay, so the number that I'm going to get will be 00. I think I am doing it at the wrong place. So these two bits will come at this position. So the number I'm going to get is 111, and rest will be 0. Right? So on and so forth. So this is the, let's take one more example so that you can understand it better. Any number, let me take, let's say I have 101101110. Fine, let's say this is your number, and rest are zeros, needless to say. Now I want you to shift it by 3 when you are doing a left rotation. When you do a left rotation, then you are moving the 3 bits from here to here. Okay, so each of the bit will be shifted to the left positions by 3 times. Okay, So the number that you're going to get will be 1 will come here, 0 will go there, 1 this and like this. So finally the number you have is 10110, and each of these bits is coming here appending one by one, then 0 comes and then 1 comes, right? This is how you're going to get the number. Then it becomes 101. I hope the question is clear to you. So the original number was, let me just write the original number again. So 1011011, that was your original number. Now you got this number. If I want to do right shift, right rotation, then what it is going to be, right rotation means the last 3 digits I am going to just remove them and place it here. So that's how it is going to happen. You shift each of them by right by 3 times. So when you do so, what is the number that you are going to get? So once when you do so, 1011, 10110, and 0 will come here, then 1 will come here, then 1 will come here. So this is the number that you are going to get. I hope the rotations are clear to you. Now how can we handle it using bit? How to handle them using bits? So very evidently you might have observed one thing, that if I do a right shift on the number, see what I'm doing eventually, I'm doing a right shift on number by, let's say, right shifting it by 3 times. What must be happening? Let's say I'm talking about right, then you can obviously understand it for left. Let's do for 1. So this was your original number written in blue. I shifted right. What is right shift? You take off the last 3 bits, okay, and then you append zeros here, so 3 zeros, and then what is the number you're going to end? 101101, right? Sorry, not 01, just 0 in the end, because 110 have been taken off, because you wanted to shift. When you do a right shift on this number, this is n, you are doing n right shifted by 3 times. So this is what you're going to get, okay? Now tell me one thing, how many bits were there in this number? 1 2 3 4 5 6 7 8. 8 bits were there in this number. How many bits are left? What are the remaining bits when you shifted it? You basically took the 3 bits and and you wanted to get rid of them, so you did a right shift, okay? So this is the number that you found. Now the number of bits that are left in this n will be, how many bits? We calculate 7 minus 3, 4. 1 2 3 4, am I right? 1 2 3 4 5 6 7 8. N is 8. So 8 minus 3, 5. There are total 5 bits left now, okay? So what I want to do in these 5 bits is that you are going to do a left shift on n by 5. What are we going to achieve from this? I'll tell you, but just have a look. So if I do a left shift on this number by 5, let me just check if you guys are able to hear me. Okay, left shifting this number by 5 means I am taking off the first 5 digits from this number, okay? So when we did a right shift, we removed the last 3 bits. Now I am doing a left, sorry, I think, what did I do? I am telling you right shift, right? So now left shifting this number by 5. This is a little bit confusing, shift and rotation, okay? So taking off the first 5 bits. So the number that you're going to get is 110. Fine. 110. Left shift by 5. And rest will be 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I'm not wrong, this is what we are going to get. Now these are 2 parts of your number. Fine, these are 2 parts of your number. If you see 1011, 10110 can be found in the first 5 digits of your number, right? You can observe it in the first 5 parts of your number, and the last 3 parts which you want to shift by right can be found here, right? So this is, our target was to basically separate the number of times I want to shift this number. I must have what all parts, because anyway I want both these parts in my number just rotated by some number, right? So I want these bits, all of these bits to be present in my number just rotated by some digits. So I want to save them somewhere. That is why I've stored them like this. What I did a right shift on n by as many times I wanted to rotate it. Okay, then the remaining numbers also, bits also, I wanted to store somewhere. So this is the reason I did n left shift by n, basically how many bits minus d times. Correct? If this is d, then this is x, where x is the total number of bits, total bits you can say. So x minus d times. Okay, now you do a bitwise OR on both these. Let's say this is a and this is b. So bitwise OR on a and b, what are you going to get? So wherever you have 1, you're going to get 1 there. So this with this, it is going to be 1. This with this, 1. This with this, 0. This with this, 1. This with this, 0. This with this, 1. This with this, 1. And 0 with 0, 0. So we have gotten this number. Have we done this right? Let us check. So didn't we want this? Let's see what was the right shift on this number. You can see 1101 0 110. Didn't we get this right shift on the number? Yes, we did. So that's all about it. So let's say one more development that I want you to understand in this question is, how many bits are these? These are total how many bits? 8 bits. Okay, and let's say in my problem statement I say you that I want you to return me answer in only 5 bits, right? So whatever 5 bits you have, just return me those 5 bits. So what can you do? What can you possibly do? Can't you do one thing, that you do a bitwise AND with 5, with a number which contains 5 number of ones in its bits, as it only has 5 number having 8 bits. So if I only want number having 5 bits, do one thing, 1 2 3 4 5, and rest will be 0, right? If I choose a number which has 5 number of ones in its bits, so what kind of a number it will be? It is basically 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4, right? So this is going to be, if I calculate in terms of decimals, 0 1 2 3 4, 16 plus 8 plus 4 plus 2 plus 2 to the power 0 1, right? So this is the number you're going to get. So how much is this? 8 4 2. So this is going to be 24 4 2 5 3 7 7 8 15 15 and this. So you are going to get 31, correct? So basically in terms of decimal, you are taking a number 31. So you selecting a number which is equivalent to, now what you can say, the number is equivalent to 2 to the power, so 16 is 2 to the power 5 minus 1, right? So didn't you choose a number like this? That is 2 to the power 5 minus 1, right? That's for you to understand that what kind of number I will be choosing. So finally, what are you going to get? You are going to get a number which is, let me just erase this. So if you want if I have defined that I want a 5-bit number, so you can choose a number that is equivalent to 2 to the power that n, whatever I have given you, minus 1. That is the number that you can choose, correct? Okay. So what I'm going to do, I'm going to do bitwise AND with this number that I have chosen, which is to the power 5 minus 1. So this will be what? And I'm doing a bitwise AND with it. So I am going to get, it's a 0, it's a 1, it's a 1. Wherever in this number, wherever I will have 1, I am going to get a 1 there, rest will be 0. Okay, so this is 0, this is 1, and rest will be nullified. Okay, so finally, basically I wanted the last 5 bits of this number. That was my demand. That is the reason I made this manipulation. I hope you all understood this problem, and that's exactly what we can do vice versa for left shift. This we did for right. You can do the similar thing for left shift. So let's move to the code. Let me check if you guys are able to see my screen. Yes, I think. Yes, now I'm going to code this question. You can check it here. So in code, what can we do? The similar thing I told you. The only extra things that I'm going to do is that this D, I don't know what if they have given us the limit. Let's say this D exceeds the number of bits that we want to return. So I am just taking the remainder of D. I am storing D with remainder 16, D remainder 16, so that if D exceeds, because see, your question clearly says that N is stored as using 16 bits, so any number that we are taking will be taken as 16 bits, so that is expected that you also return a number whose binary representation has 16 bits of digits, right? So if let's say D exceeds 16, that means it is asking you to rotate 17 times. So rotating by 17 means what? You are actually rotating that number by one time only. That is why we have done D remainder 16. Okay, now next thing is that I am choosing that because I want a number to be 16 bit. So I told you finally I will be doing an AND with that number, which is equal to 2 to the power of the number of bits I finally want in my number. So that is not an issue. I don't need to write that number. I can tell you, since we want a 16-bit number, so 2 to the power 16 minus 1, 2 to the power 16 minus 1 is 65535. This is the number you will get when you evaluate 2 to the power 16 minus 1. Okay, so that is what we are going to use. So let's move, and int x I am taking, that is the number of bits is 16. That is what I am taking. So now let's evaluate the left number that you want to store into an array list. Let me just take an array list of integer. Result is new array list of integers, right? So this is the array list that you want to store with. One will be your left answer, other one will be your right answer. So int left will be equal to this capital N. You are in your left, you are left shifting your N by D digits, left shifted by D. Then you are doing a bitwise OR with what? N right shifted by number of bits, total number of bits is 16, right? So let me just directly write 16. Let me take it x so that it is easier. So x minus D times, right? So after this you are doing a bitwise AND with 65535. And why are we doing so? I told you 65535 represents 2 to the power 16 minus 1. This is what it represents, is equal to 65535. This is the reason we are doing it. Okay, then you can calculate right also. Right is exactly this, means expression will be just opposite, which is like this. So you are in right, you are first right shifting the number by D times, doing a bitwise OR with N, getting left shifted by x minus D times, where x is equal to 16. Okay, and then in your result you add these numbers left and rest dot add right. Okay, fine, return rest. Let's see. Let's submit it. So you can ask if you have any doubts meanwhile. So this problem is done. Let me just check if you guys have any doubts. So that was all for today's problem. I hope you understood it. If you have no doubts, then we will wrap it up. Okay then. See you all.